Hello and welcome to my presentation. I will be reviewing the paper Self-Learning and Self-Adaptive Resource Allocation for Cloud-Based Software Services. I will discuss the main points of this paper, its relevancy, and give some critique as to limitations found in this paper. This paper was published in 2018. It was a special issue paper published by Wiley. When applying autonomy in a system, a software engineer must develop the control system that allows the system to adapt. Not every system will be able to operate off the same pre-configured set of policies or limitations around the governance and available resources, number of available resources, and expected amount of data flow. As such, each system will likely require an engineer to design a unique model. This results in high administration costs and has a constant level of complexity. Moving away from the traditional methods of implementing autonomic systems tends to be accompanied with greater complexity in both design and implementation of the new system. This is no different with this paper's approach of self-learning systems. There is a constant attempt to improve upon the standard. While most systems currently employ the more traditional, though rigid, policy-driven model, there are other models that attempt to improve upon this limitation, often found with traditional policy-driven models. One such model is the rule-based approach. This method is very fundamental in that it simply applies expert-made rules for storing, sorting, and manipulating data. Another method is dynamic resource configuration. This model uses knowledge management techniques such as care-based reasoning on top of a rule-based approach. This attempts to reconcile the lack of knowledge in the policy-driven model, though it is limited by the need for user input for any new information or knowledge that the system may need. Another attempt to improve the policy-driven model is the adaptive policy-driven model management system. This model uses reinforcement learning methodologies to find the best set of policies to use to meet the various performance objectives. This paper presents the notion of using machine learning and genetic algorithms to achieve a better response with the ability to predict future allocations and adjust to them in real time. The name given to this is self-learning. This is achieved by developing a quality of service model by training a system on historical data. This is then used for online decision making, which uses a genetic algorithm to allocate resources by using the model that has been developed. A benefit of the self-learning model, compared to the more common policy-driven models, is that the system can be applied to a greater variety of systems, removing the need for an engineer to develop a unique system per application. Over time, a system may need to be changed, possibly to accommodate for new systemic changes in a system. Having a self-learning system would allow the system to identify, remember, and adjust for the systemic change. This further benefits the system's performance over its policy-driven counterparts, as a policy-driven model is incapable of learning and thus predicting. While this is a very interesting theory, it does need some evidence of this application holding true to these claims. To validate whether this model, trained from historical data, can predict an output value using information on workload and allocated resources as inputs, the authors used a RUBIS benchmark. RUBIS is an eBay-like prototype auction site that is mainly used to evaluate an application's server performance scalability. This was used to simulate various workload patterns in a private cloud. To test the system across a better range, 3 virtual machines were established, each with their own amount of memory. To collect data for testing, they collected runtime data for 2 weeks based on these 3 virtual machines. Here we can see the outputs of the testing that was conducted. A rule-based model was used to set the standard. On the left, we have a comparison of the resource costs. In both tested workload trends, the new model outperformed the rules-based model by considerable margins. On the right, there are bar graphs denoting the response time and quality of service between both models under the same workloads. The upper two plots denote the workload with a less intense cycle. The lower two plots denote a more intense workload cycle. The upper two plots show rules-based models outperforming the new model in both response time and quality of service. However, the lower two plots show the model outperforming the rules-based model. Something else should be noted is the stability in the new model across every plot compared to the rules-based model. This shows a less volatile nature with less of a tendency to overshoot. A limitation of a self-learning system is the need for historical data. When a system is new to the market, there is a possibility that there is not any relevant historical data available. This inhibits the ability of such a system training a quality of service model, at least until sufficient data can be obtained. The data collected in this paper and displayed showed minimal improvements over the rules-based model it was compared to. For a better comparison, more data would need to be collected. This concludes the presentation on self-learning and self-adaptive resource allocation. Thank you for your attention.